Yeah.
Great. So minus 2x squared is a monomial.
Monomial.
And it's monomial because there's one of them. X squared plus 3x minus 4 is a trinomial because there are 3 terms.
Mm-hmm. And then
One,
if there's more than 3, it's something like is it like a binomial or something like that?
well, yes, a poly is used to describe more than
Oh,
one, but
polynomial.
probably most of the time it's used like it's like a monomial is a polynomial, but a polynomial is not a monomial
Mm-hmm.
necessarily. So uh to
My Wi-Fi just like trashed, so I'm not sure how long I'll be on this.
yeah, I'm noticing some issues on my side too. So it may be me more than you, but let me know if the issue continues.
Okay, sounds good. I still hear you and like see everything
Are you
fine.
seeing my screen?
Yeah, everything's
Excellent.
working fine. I just got like a warning.
Okay. All right. So in terms of like, what is this? This is a monomial times a trinomial.
Trinomial.
Okay. So that's how you would look for that on your exam. Now, it doesn't say that specifically. It actually labels this as monomial distribution,
Mm-hmm.
which these are actually the same. The reason it's distribution is you're multiplying it to all 3. So that's the correct sort of label here for letter A.
All right.
Now let's get to the actual multiplying step here. So when you multiply in, the one thing to remember here is if you have the same base and you're multiplying, you add the exponents. So you add the exponents. So like x squared times x squared is x to the 4th.
Mm-hmm. And
There's a
then
1 there, so that's -2,
negative 2x, negative 6x to the third power,
right? Plus 8x
negative
squared.
8x squared.
Yes. The main thing that students forget to do is to distribute the negative or distribute to all 3.
Mm-hmm.
You got it right, so I'm not sure.
Yeah, when it comes to the actual math part, that's what I under that's what I get like the most is just the letters that were like messing me up.
Yeah, you'll get it here pretty quickly though. Okay, so letter B. This is a trinomial.
Trinomial. All right.
This is also a trinomial. I'm trying to think of a good analogy, but it's like we use the word monomial, binomial, and then a trinomial. And then we stop like trying to come up with words and we just say polynomial.
Mm-hmm.
So I don't have a good analogy for that, but like
Yeah.
polynomial could refer to any one of these. So it could be, this could be referred to as a polynomial. And this could be referred to as a polynomial.
All right. It's because so when there's 3, it's a polynomial and a trinomial.
Yeah, so like the trinomial is the more specific thing.
All right.
Uh whereas polynomial is kind of a overarching, like it's correct, but it's not specific enough. I don't know why I can't think of a good analogy
Yeah, I
to
mean it's
this.
kind of like a tricky thing to compare.
Yeah, it's like I don't even know where to go because there's like, I was thinking about using vehicles or cars. Um, you play sports. It's like, well, that's a tennis ball, that's a golf ball, that's a basketball, and they're all balls. But
Mm-hmm.
I mean, you could refer to a basketball as just a ball, but it's more specifically a basketball kind of thing.
All right.
So to like, if you go up to what it actually is in your exam, and this is what's going to be much more helpful. Do you see the math operator between the two?
Yes, subtraction. Or
That's it.
minus.
Yeah, and that's going to be a big giveaway for these. So that's why it's a polynomial subtraction problem.
Yeah, I don't really know how I got that one. Like now looking back at this, I was like, oh man, that was an easy one.
You know, hindsight is 2020. You have more clarity when you do it again. It's okay. So now when you subtract, this is key here. You have to remember to distribute the negative to both terms. Or all three terms, I guess, in this case. So when you distribute it to all three terms, you get, I guess maybe I should even just rewrite because we did a lot of sort of talking about it. Because as you said, you already know the math. You drop the parentheses because you don't need it, because there's no operator outside here, but here you have to distribute this into each. So minus 2x squared plus 3x plus 2.
So you do, since it's a minus in the middle, I wouldn't do the thing where it's like I multiply like 3x squared by 2x squared and minus 3x and minus 2, and then like moving through like minus 4.
There's really like a -1 here. And that's what you're distributing to each one.
All right.
If there was an x here, you would be distributing it to each one, but it's held there by the negative sign. That's why the parentheses don't go away.
So then my question for D, it's like the same exact thing, just except there's a plus instead of a minus.
So with plus, you don't need to, you don't even need the parentheses. So the only time you distribute or draw the arrows is when, well, okay, I see what's going on here with you. I think the confusion is the order that these appear. Like typically you learn D first, then you learn B, and then you jump into A and then like C, for example, because B and D are adding and subtracting. You're just combining like terms.
All right. And then if there's no symbol in the middle, then you have to do the multiply.
Well, it's implied. It's like, well, it's implied multiplication there.
Okay, that makes more sense.
So while in B you're distributing the negative, it's essentially a subtraction problem. Like it's really because actually like the way this used to be taught in some textbooks and maybe still is you actually line this up vertically. And then it's 3x squared minus 2x.
Kind of showing us that.
Yeah, and sometimes they still teach this. It's like you know, you're certain ways of presenting the same problem. The reason you distribute the negative is so that you can combine like terms, but you still end up combining the same terms, 3x squared and minus 2x squared. And then you still end up combining minus 4x and 3x. Hopefully you follow that.
Yeah, I do.
Okay.
It's just like another way of writing it, really.
Exactly. So however you want to do this, you have to be comfortable with distributing the negative only, just the negative. Okay. All right. And you have done that correctly here. You said, okay, it's x squared minus x plus 7.
X squared minus x plus, yeah, that's what I got.
Yep.
All right, so then that would be a polynomial subtraction.
Yes. Okay, can we go to C?
Yeah, of course.
Okay, C next. All right, so C is a binomial because there's two terms. This is a binomial. And this is also a binomial because it has two terms. So it's a binomial times a binomial. But if you go back and look at like the top, you'll see that there is no, oh, actually it does have it. So your instructor is being, it's like in this case, your instructor is being very, very specific. And in others, your instructor is not. Like This
Yeah,
could
that's kind of
also
what
be,
helps throw me off there.
yeah, this could also be a polynomial times a polynomial. Although it's not the most specific like thing
Mhm.
that it could be.
So polynomials like 3 and over. And then times
Polynomial could, to me, polynomial, the root word is poly. To me, that means more than one. I mean, let me go check here. What does poly mean? To me, it's more than one.
Okay.
But but this is one of those things where your instructor could either not know, not want to make a differentiation.
Oh,
Like it might be a good question to even just ask, and I'll just type it in here. Is it okay to refer to a binomial as a polynomial?
all right. I'll ask her that for
And
sure.
then similarly, is it okay to refer to a trinomial? And these are like, to me, the answer is yes, but you should get confirmation with the person grading it,
Mhm.
because that's what really matters here. Okay, so
I'm definitely
this
gonna.
is good. Sorry.
Oh, I'll make sure to ask her that.
Okay, excellent. So so the actual like math here, the actual like mechanics is what I call it, is you have to, this is actually what's called a FOIL problem.
FOIL problem.
You multiply the first times the first, that's F. Then you multiply the outer,
Mhm.
then you multiply the inner, and then you multiply the last.
All right. And
So
then it
it's,
also looks like it's kind of foiled together, like in the shape.
yeah, exactly. So this is 2x times x plus the outer is 2x times 5. Now this plus means it's always positive 5. This minus means it's minus 4.
Mhm.
The inner is minus 4 times x, and the last is minus 4 times 5. So that's your F, your O, your I, and your L.
Yeah. So then 2x squared plus 10x minus 4x minus 20.
And generally you combine the O and the I.
And then 2x squared plus 6x minus 20.
Good.
And then this would be, all right. I guess it's definitely not a trinomial.
No, it's a
I think
binomial
if it,
times binomial.
so then that would be C,
Yes.
binomial times binomial.
Right. But it could be a polynomial times a polynomial, but that's what we're trying to gain some like
Yeah,
clarity on. Like, is that actually the case? Um, and it is, in short.
yeah. Okay.
Okay, let's move to letter D. Oh, small point here. Do you see like there's an implied multiplication right there in the middle? That's implied between the two. You have to know that as a student. You can't like pretend like you didn't know that there's a multiplication there. This one, letter D, is very clear. It's a, okay, here I have a big plus operator. And this on the left is a trinomial, but it could also be referred to as a polynomial. And this is a trinomial. So do you see that this is a trinomial and a trinomial, but you're adding them? Oh, you're not there.
Oh yeah, my Wi-Fi just went down, but I'm back now.
No problem. Where did we get up to? Did you get this last line here?
Was that for C?
Yes.
Yeah, we got to C. And I was talking, then I was like, oh, he's not talking. I was like, oh wait, my Wi-Fi just crashed.
Yeah, I have a note here to look into telling me when someone leaves the room, because this happens a lot where people get disconnected and I have no idea. So we're looking at letter D now, and there's a big plus operator.
Mm-hmm.
And so like that tells you something really significant here. It tells you this is a plus operator.
Yeah.
Okay. Now,
Okay.
when I look at your exam at the top, or that sheet that you sent to me, like to me, when I see that, I see on the left there's addition, subtraction, division.
Mm-hmm.
And like that's like, oh, I'm looking for those. I'm looking for something with an addition, a subtraction, and a division. Like that would be how I'm sort of like organizing, where to go from here.
Yeah.
So the plus sign, unlike the minus, sorry, I can't quite get this framed right. The plus sign, unlike the minus, there's like nothing to do. You don't actually need the parentheses.
Mm-hmm.
So you just drop them.
So just yeah, I guess 3x squared
Right. And but
minus.
I'm gonna rewrite it one line without them, and then
All right.
I'll take your answer there. Yeah, you say, oh yeah, okay, that's 3x squared.
Actually, wait. So on this one, so the x squares, would it become x to the fourth power?
You're adding them. So when you add x squared plus x squared, that's 2x squared. X squared times x squared is x to the fourth.
Okay.
Which are you doing here? You're adding.
Okay. So then 3x squared minus 10x plus 5.
Very good. Now, in terms of which one this is, that I was trying to show you here, it's a trinomial plus a trinomial, but you can say, oh yeah, let me just call it a polynomial.
Mm-hmm.
Let me just call it a polynomial. And that's why it's polynomial addition.
All right.
Okay, let's look at letter E.
E. Okay. Wait, so D would be polynomial. All right, wait. So that is polynomial addition.
Yes.
Okay. Yeah, man. I wish I knew like what her definition is for the difference between those two. All
Yeah,
right. E.
unfortunately, it's poorly written, so you just have to deal with that. So this one, what is the operator right there?
I 1x. I guess it's like not there.
Okay, so operators are like multiplication, division,
Oh,
addition, subtraction.
multiplication.
Right. So so this is a multiplication problem. How many terms are here?
A binomial and a
Binomial.
trinomial.
That's right. So it's a binomial times a trinomial. Do you happen to see that on your sheet?
Yes, I do. I see that as the last one.
Yeah. So you got to recognize first that it's multiplication, then and so I say it this way, like if you see something squeezed together, to me these parentheses are squeezed together, whereas in the previous problem there's more space between them.
Mm-hmm.
That's an indication of multiplication.
Yeah, so then you gotta multiply it together. So that would be x to the third power minus 2x squared minus 3x, and then plus x squared minus 2x and minus 3.
So notice the way I wrote this, which is a little bit different. It's more like when you were asking me up here about another way to write the subtraction problems, where you vertically align
Mm-hmm.
the like terms. So what I did is, and I could doing a lot of these, it helps, but you want to line up like terms. So these three come from the second distributive part. And when you line them up like this, it's a little easier to add than just having them in a straight line. You would for sure believe me if this was a trinomial times a trinomial, because you'd have a lot more terms. You'd have another 3 terms here.
Yeah.
So in short, you still have to combine like terms, but so this becomes minus x squared minus 5x minus 3.
All right. Yeah, I guess it's cool that there's like another way to do this. Well, most of the ways is just one.
Yeah.
All right,
All right.
and
All right. Letter.
binomial times a trinomial.
Yes.
All right. I guess I'm ready for F.
Letter F here. So letter F is a and you first notice you're first looking at the operator. What's the operator? And again, it's like multiplication, division, addition, subtraction. Oops, subtraction.
Division.
It's division. Okay. So that tells you this is a division problem. Up top is a binomial. On the bottom is a
Singular.
monomial.
Yeah, monomial.
Monomial. So it's a binomial divided by a monomial.
Monomial. All right.
Now you might think, well, okay, that's great, Matthew, but I don't see that on here. You're right, because your instructor has yet again used a different set of language. So, this is one of those where you could actually, if you wanted to be a difficult student, you go back and say, well, Mr. Instructor, this actually isn't a polynomial down here at the bottom. But as I said, like polynomial tends to cover like monomial, binomial, trinomial. So it depends on the definition, but the polynomial division is generally referred to means like it actually has to be a binomial or greater, because poly means more than one. Like we go to what the root word means. You gotta, unfortunately, you have to clarify that with your instructor.
Yeah.
What I'm telling you is completely correct, but I don't grade your stuff. That's why I got to go with what they want.
Unfortunately.
Yeah. Okay. So here, and this is very important. Do you see how I wrote these parentheses on the top?
Yeah, I do.
These are implied. And when I say implied, it's just like in the previous problem where it's implied that you're multiplying. And that means you're supposed to know that. You're supposed to recognize, oh yeah, there's parentheses there, even if they're not written. And the reason is because when you go to divide, it's not a choice. You have to do it to both. Oops, get that down here. So when you divide, you're actually writing 4x squared over 4x plus 8x over 4x.
4x plus 8x. All right. So then I guess it would be x squared plus 2x.
So the 4's cancel. You've got x squared up top. So one of
Oh,
those.
so then would it just be x?
Yes. Now another way to do it is if you have x to the n over x to the m, this equals x to the n minus m.
All right.
So you get plus, and then these cancel, and then the x's cancel, so you get
2.
2.
All right. Now I see why I didn't get that one.
Okay, so do you really think you're gonna need exactly the same ones?
Yeah, she said that like at first I even had that like several people asked her like, are you actually doing these same exact ones?
Okay.
Yeah, like these are the exact same things. And she wants like, I don't know, I have a really like bad class. Like it's a lot of
Okay.
people don't
So
pass.
here's how what I would recommend, and you can decide yes or no on this. I would ask you to put away whatever notes you have, get a fresh sheet of paper out. Don't have anything from what we just did in the last 30 minutes up, and we'll just go through them in order, and you try and do them again and tell me what it is.
All right.
So if you are in agreement with that, we can certainly do that.
Yeah, let's do it.
Okay. So you let me know when you're ready.
All right. Would you mind just putting in the like problems just like in the viewing point of this document for me so I don't have to look at the other paper?
Yeah. I'm gonna put everything in here. Like all I want you to focus on is what I'm asking you to do is put everything away from any
All
notes
right.
any notes you currently have.
Yep.
And
All right. Everything's
you're all
put
squared
away.
away. Okay.
Totally.
All right. So here is your first problem. And I'm not necessarily going to do it in order. So that'll maybe be another helpful thing.
All right.
So again, here's your first problem. And I want you to decide which of these 6 this is, and then we'll do it, then we'll have you do it.
All right. I think it's polynomial subtraction.
It is a polynomial subtraction. Okay,
All
I'll write
right.
that there. Okay, now I want you to be able to do this problem if you've got that piece of paper out. Since I can't see what you're doing, can you tell me in words what you're doing first to simplify this?
Okay, I'm going to since there's the minus there, I don't have to multiply it, so I have to subtract the 3x squared and the 2x squared. So it would just become x squared.
Right. I would love, so you kind of do distribute this negative to everything. It's kind of the right language.
All right, so would it be like negative 2x? Oh, right, negative 2x squared plus 3x plus 2.
Yes.
All right, forgot that is the first step. All right, so I guess you could just write like 3x squared minus 4x plus 5 in front of it
Absolutely.
too. And
So
then,
just give me your final answer whenever you're ready.
all right, x squared plus x plus 7.
It's definitely plus 7. What about that middle term?
Oh, minus x.
Yes. Very good. All right, let's do the, I'm gonna grab this again and clean slate here. All right, so again, let's first figure out, which one is this, and you really want to start with whatever operator you see.
Mhm. I see addition, and they're both polynomials, so polynomial addition.
That's right. That's right. So like there's only one addition out of these. So once you see that, you're like, I got it. So this is
Yeah.
polynomial addition. Okay, so go ahead and give me the final answer whenever you're ready.
All right, so it's additions, so you don't need to like multiply it. So then you'd have it's same thing to the addition, you don't have to change any of the signs. So it become 3x squared minus 10x plus 5.
Very good. All right, let's do the next one here. All right, what say you here when you see this? What's the first of all, what's the operator?
Multiplication.
It is multiplication. Okay, so it could be one of these times, but
Right,
distribution,
the first one isn't a binomial.
yeah, it's not a binomial, so it
So that
must
leaves
be
you only with monomial distribution.
monomial distribution. Yeah. Great. Okay, so give this one a try, please.
All right. So there's the minus symbol, obviously. So it'd have to become, and also since it's multiplication, the x's will change with it. So it'd become negative 2x to the fourth power minus 6x to the third power minus, I mean, plus, because there's two negatives, plus 8x squared.
Very good. All right. All right, so let's see what the next one brings. Let me see if I can get back to, why don't I have that open? Oh, there it is. All right. Again, I'm not going to quite do this in order because
Yeah,
that doesn't help you to see it exactly in the same order. But I mean, again, like I just can't believe you're going to get this.
I know. I'm super glad too.
All right. Okay. So again, start with the operator. What operator do you see?
I see division, and
Division.
there's
And
only one
there's only
division.
one division,
But
so it must be that one.
so then you have a
And it's not a choice. You have to do it to both.
Yeah, divide both. So then it would become just x, because once you divide 4 and 4, that leaves you with just 1, and you can't have 1x. And there's the
Mhm.
2 to the second power and 1. It'll just be 1 minus 2, because the x's will divide each other out.
Good. All right. Let's go. Let's go for all right. What do you see here?
All right. I see two what polynomials, and their
What's the operator? Start with the operator.
multiplication.
Okay. So that means it's no, 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 maybe, maybe, maybe.
I guess binomial times my binomial.
Yes. Now what you said is true. It is a polynomial times a polynomial according to Matthew.
Oh, right, and then there's the 2, and binomial is 2. So
yes, binomial times a binomial.
binomial. And then
Okay.
that would become since it's multiplication,
Yes.
the x's will become bigger than what they originally are. So then
Yeah, the exponent increases when you multiply.
so then it'll become 2x squared plus 10x minus 4x minus 20.
Okay, is that your final answer?
And then you have to keep dividing just the normal x's, so then you'd have 2x squared plus 6x minus 20.
Very good. All right, last one of these.
All right.
Did your teacher provide this piece of paper like as a download on the classroom workspace, or?
Here, let me go check super
Oh,
fast.
no, not quite. If you don't mind, just
Oh,
wait to do that. The reason I'm asking is because that's another way you can practice this, before the test, is just print it out one more time and see if you got
figure
it.
just for myself.
Again, so start with the operator. What's the operator that you see right there?
I see multiplication.
So it's like no, 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 because it's not addition, subtraction, not division. Maybe, maybe, maybe. We just did binomial times a binomial, so it's not that.
So I see binomial, which is 2, and a trinomial, which is 3. And I see 2 and 3 right there. So
Yes.
binomial times a trinomial. So then you have to, since it's multiplication, the exponents will rise,
Will increase, yeah.
will increase. So it would become x to the third power minus 2x squared minus 3x, and then plus x squared minus 2x minus 3. And then you would have x3.
Yeah. So again, my preference is to move is to put these here so that they line up.
And then you can just do it easier.
But it does take a while to do that. You might even catch yourself doing it like this and then saying, oh, I should have put them there. Someday you'll be like, oh yeah, okay, let me buy into that. But go ahead. So you got x cubed.
X cubed minus x squared minus x minus 3.
You're combining those, right?
Oh, minus 5x
Minus 5x minus 3. Yeah.
And then that's your final.
Yeah. Okay, so we did all 6. What would you like to do, if anything, for the rest of the time here?
Here, let me check my folder really fast to see if there's
Sure. Sure. I'll stand by here.
I mean, honestly, everything's looking like pretty good for the class. Like all we've been doing is this. Maybe we could just do a couple more like problems like this, just since this seems kind of relevant.
Sure. So there's a couple here I saw that you kind of that you weren't as strong with. So let me just give you a couple of those and we'll see how you go. So let's say it's 8x squared minus 4x over 2x. I'd like you to simplify that, please.
All right, you'd have 4x minus 2.
Good. Okay, so that was pretty straightforward. How about x minus 1, 2x squared minus 3x plus 4. You can multiply that out, please.
All right, you'd get a 2x to the third power.
Go ahead and give me your final answer. Just
All right.
you can talk it out if you want, but just let me know when you're ready for the final answer.
All right, sounds good. I got 2x to the third power minus 5x squared plus 7x minus 4.
All right, so let me work this out here, and then if you see something different, let me know. But get this here. So minus 2x squared. So 2x cubed. I think I heard it's minus 5x squared plus 7x minus 4. Is that right?
Yes, that is correct.
All right, let's do one more here. Okay, so give that one a try, please.
I think I got it.
All right, give me your final answer, please.
Minus x squared minus 9x plus 1.
Yep. Well, those were the couple that I thought you didn't do correctly, either just because there was a sign error or something minor, but my recommendation is not to do anything more if this truly is your test. Like I know I've said that a
I'm
bunch
just
of times,
only
but
going to do these problems and get those down.
did you check to see if that sheet is still available? The one that you sent me. If it's not, what you want to do is just make
a copy of it.
Yeah, without any of the work. And maybe if you got access to a copier in your home, just copy it one time. Do it 1 or 2 more times, and
yeah,
you'll be fine. You'll do it so fast you'll wonder if you did anything wrong. That's
the
problem. And that's the problem when you do stuff, the same stuff over and over again. You
start doubting yourself.
Yeah.
It's kind of funny, honestly. Yeah. All right. I don't think it's here, but I can just copy it down.
Yeah, I'd write it down, and then you'll have it. So this is as good as place as any to stop if you're okay with that.
Yeah, it sounds great to me. Thank you.
Great. Thanks so much for scheduling. I'll send you the notes.
Letters sorted out for me. Got that now. So
yes.
The only part I was nervous for.
I'll send you the notes and the screen recording out shortly.
All right. Thank you, Matthew.
You're welcome. Have a nice day. Bye now.